One of the most popular pieces of speculation has become known as the Big Bounce, in which the universe is eternal but transitions between an expanding state, described by the Big Bang, and a contracting one, known as the Big Crunch. The idea of this endlessly inflating and deflating cosmos has been around since the early 20th century, but it was only in the last decade or so that physicists have discovered how it might be possible. The theory posits that in the very earliest moments of the universe, everything is so small that reality is governed by quantum mechanics. The strange properties of the quantum world mean that a contracting universe can be saved from complete collapse by quantum tunneling from a point just before the collapse to a point just after it, transitioning instantaneously from a contracting space-time to an expanding one. At the other end of the universe's timeline, after a Big Bang-style expansion for billions of years, it's hypothesized that the density of matter in the cosmos will have sufficient gravity to overcome the force driving expansion and eventually reverse it. But the latest observations of the modern universe suggest that the expansion Hubble saw back in the 40s is not, in fact, slowing down, but is actually accelerating. This is a spanner in the works for the Big Crunch, but there is another option. In 2010, British theoretical physicist Roger Penrose presented a new theory of conformal cyclic cosmology, founded in some of the most complex mathematics and theoretical physics available to cosmologists today. The model relies on the concept of conformal geometry, which concerns the geometry of shapes, irrespective of their size. A chessboard has the same geometry, the same number of squares, the same aspect ratio, regardless of how big it is. Whether it's a tiny pocket-sized board or a huge garden set, the game is still played the same. And these principles apply to our own universe at the points in its history when we lose track of scale. One of these points is in the murky, high-energy instant just before the Big Bang. The other is in the far distant future when black holes have swallowed everything and the overall energy is so low that all space and time cease to have any meaning. Although many would consider a tiny hot universe and a huge cold one to be about as different as it's possible to be, according to conformal geometry, they are equivalent. A huge cold universe at the end of its life behaves just the same as a hot one at its beginning. Penrose uses these mind-bending principles to reason that one naturally leads on from the other, that we are living through a single eon of our universe, and that in a googol years or so, the loss of scale at the death of the universe will lead to the Big Bang of a brand new eon, and the beginning of a new history. In both the Big Bounce and conformal cyclic cosmologies, our Big Bang is both a beginning and an end, and is just one of many Big Bangs in the endless stream of universal existence. But there is an even stranger theory, with its origins in strings. In the spring of 1995 at the University of Southern California in Los Angeles, the American theoretical physicist Edward Witten made an extraordinary announcement that was music to the ears of string theory scholars worldwide. String theory models have been developed over the preceding 50 years to explain the fundamental nature of matter on an unimaginably small scale. It claims that all particles are ultimately composed of one-dimensional strings that move through space and interact with one another. But to explain everything in our universe, different versions of string theory argued that there must be other entities with more dimensions, two-dimensional sheets or three-dimensional volumes, and even more. This model, which was intended to unify all of physics, had done little more than divide the scientific community. But Edward Witten rejected such divisive thinking. He conjectured that all the different versions of string theory could all be true, if they were incorporated into an 11-dimensional reality. His proposal of this so-called superstring theory sparked a flurry of research and offered a new, if perplexing, possibility. In superstring theory, space-time is described by no less than 11 dimensions. In this theoretical framework, our own universe, which we experience in the 3 dimensions of space and 1 dimension of time, can be considered a mere portion of the whole, a so-called brain in the bulk of hyperspace. Physicists suggest that our universe developed from the energy released when higher-order brains collided. The energy from the collision provides the motion force for the Big Bang and subsequent expansion of the universe, but it can't last forever. Tension between these higher-order brains will cause them to retract and recollapse after a mere trillion years, bringing an end to our universe that we are unable to visualize or even comprehend. This heady theory is known as the Ekpyrotic Model, referring to ancient myths that see the world born in a fiery explosion. For now, we have no tools to detect the higher dimensions if they really exist, so like the other theories that try to explain and justify the cosmos, they remain little more than highly informed speculation. But the Big Bounce, the conformal cycles, and the ekpyrotic brain cosmos are all possibilities that lie at the bleeding edge of modern cosmology. Like all good theories, they try to make predictions that we can test through observation and experiment. But so far, no evidence has come to light to give us any real clue. Our understanding of the cosmos relies, like a house of cards, on our understanding of physics and mathematics, which continues to change and evolve. The true nature of the Big Bang and the meaning of the universe as a whole may always be incomprehensible to our monkey brains. Or perhaps a new revelation will turn everything on its head tomorrow. We can only keep asking and trying to see through the fog.